So I already recorded this video and then found out that my little thing stopped sharing all by itself. So this is the second half. Hopefully you'll like it just as much. All right, so we are going to add and subtract expressions. Adding and subtracting rational expressions should make you feel super excited because rational means fraction, which means we have to follow all of those fraction rules from back in the day. And when you add or subtract fractions, you need a common denominator. So we're going to find a common denominator with variables and factoring and all sorts of good stuff. So here are the steps. You're going to find a common denominator, and then I call it fix the numerator. That's not what it's really called, but that's what it's called in my head. After that, you combine the numerators, but you keep the denominators the same, and then simplified like we were doing before. So let's start without factoring and see how it looks. So here we have to check out our denominators, and our denominators are the same, which is awesome. So we get to skip the factoring step and start right with the combining step. So we keep our denominator the same and we combine the numerators. I recommend you write it all out. I know it seems like a lot of work, but it'll help in the long run. Combine 13a plus 5a is 18a over 4a squared. And then you can simplify. So these are both divisible by 2. So we have 9 over 2. And I usually just do it like this. This is a really to the first. And when you're dividing, you subtract those puppies. So that will be 1 minus 2 is negative 1. And then we're going to use that negative exponent deal to swap that down to the denominator where it goes and becomes positive. So that's it. That's the gist without having to find our own common denominator. The next one is a little bit more complicated, although it does have the common denominator already. So step 1 is to keep it as it is and combine the numerators. Again, I don't recommend just doing this by eyeballing it because you will likely forget the subtraction part, the distributing of this fraction part if it has that. So I would just go ahead and write it out and then combine where you're not going to make as many mistakes. So 14k squared minus 7k over 6k squared minus 5k plus 1. And now we're into the simplifying of the expression, which goes back to the rules we were talking about before, and we need to factor first. So go ahead and try to simplify this on your own, and then unpause the video and see if you did it right. All right, welcome back. So hopefully you factored out 7k from the numerator, and you are left with 2k minus 1. The denominator, though, is a little bit more of a complicated factoring situation. So we're going to take that out to the side to factor it. So 6k squared minus 5k plus 1. So again, we're going to kind of take this out to factor, just because we need a little bit of room. All right, when we factor that, we're going to multiply 6 times 1. We need the factors of 6 positive that add up to negative 5. So of course, a lot of people instantly will think negative 6 and 1, but that doesn't work because 6 has to be positive. So we need 2 negatives. That leaves negative 3 and negative 2 as our factors. So we're going to replace the middle term. 5k is going to be replaced by negative 2k and negative 3k. And we're going to factor by grouping. I'm going to take a 3k out, 2k minus 1. And here I'm going to take a negative 1 and have 2k minus 1. So we have 3k minus 1 times 2k minus 1. And now I'm going to put that back in here. It's just nice to have some space to do work. And then we're going to cancel out any like factors. And that leaves us with the answer, 7k over 3k minus 1. All right, so now let's look at what it's like when we have unlike denominators. All right, so we have 2x on one and 3x on the other. The good news is that we have x for both, so we don't need to have more x's, but we do need the numbers to be the same. So the first thing that pops into my head is to make them both 6x. Over here, that means I need to multiply it by 3. And over here, it means I need to multiply it by 2. But remember, you can't just change the bottom of a fraction without changing the numerator because it will not be equivalent. So we need to also multiply our numerators by the same thing. So now we have 45 over 6x minus 32 over 6x. And we can proceed with our common denominator goodness. 45 minus 32 is 13 over 6x. We can't simplify that, so that's the answer. And then it looked like this. So when you get to problems like this, I like to factor the denominator and go from there. Usually I don't factor the numerator until the end unless it seems like I need to, and that'll just come up case by case. So we're only going to factor the denominator right now, but I wanted to point this out. A lot of people get mixed up and think this is a difference of 2 squares because k squared and 16, but it has to be a minus for that, so just keep that in mind. All right, here, we're going to factor out the 5, so I'm going to keep my numerator the same. But I'm going to change my denominator to 5 times k minus 2. Because now I can see we have k minus 2's in both, but we need to have the 5 also. So I'm going to put the 5 here, and I also need to do that to the numerator. So k squared minus 16 over 5 times k minus 2 minus 20 over 5 times k minus 2. We're going to combine our numerators and keep our denominator the same. Simplify k squared minus 36 over 5 times k minus 2. And I feel like I did something weird. Because this is plus 16. That's minus 4. Okay. And look, we can actually factor the top now because the top is now a difference of 2 squares. So we're going to have k plus 2, k minus 2 in the numerator, and 5 times k minus 2 in the denominator. Cancel your like terms. K plus 2 over 5 is the final answer. All right, one more. If you think you got this, then try this one on your own. Otherwise, feel free to just watch mine. All right, step 1. These are not even close. They don't look close at all, so let's go with the factoring. So I'm going to keep my 2, but I'm going to factor the denominator. GCF of 4, p minus 5, plus. I'm going to keep my p minus 6 in the numerator, and I'm going to factor the denominator. What are the factors of 15 that add up to negative 8? That should be p minus 3, p minus 5. Because negative 3 times negative 5 is positive 15, and negative 3 plus negative 5 is negative 8. All right, so you can see that our denominators are not alike, but they do both contain p minus 5. We need them to contain everything the same. So since we have a 4 on this one, we need a 4 on that one. Since we have p minus 3 on this one, we need a p minus 3 on this one. Top and bottom, numerator and denominator, to keep it equivalent. So we have 2 times p minus 3 over 4 times p minus 5 times p minus 3 plus 4 times p minus 6 over 4 times p minus 3 times p minus 5. Now the bottom's great just the way it is, but we're going to need to work on the numerator. So our denominator now stays the same. And our numerator, and I'm doing like extra steps just to show you all the steps. All right, simplify on the top, so 2p minus 6 plus 4p minus 24 over our common denominator. Combine like terms. And keep our denominator. Now we're going to factor if we can, and it looks like we can take out a 6, which leaves us with 6 times p minus 5. And we can cross off our common factors and simplify the numbers. So we have 3 over 2 times p minus 3. I know it's a little crazy, but hopefully practice will make you really good at it, and hopefully the second time was the charm.